Hexadecimal literals. Hexadecimal literal values are written using the uppercase letter X and then in single quotes val, or the 0 lowercase letter x val notation, where val, the value, contains hexadecimal digits. In parentheses we have from 0 to 9, and then we have from the uppercase letter A to the uppercase letter F. Letter case of the digits and any of the leading X does not matter. A leading 0x is case sensitive and cannot be written as 0 uppercase letter x. Legal hexadecimal literals are uppercase letter x, and then in single quotes we will have the hexadecimal 01 uppercase letters AF. Then we will have uppercase letter X single quotes 01 lowercase AF. Lowercase letter x single quotes, and inside of the single quotes 01 uppercase letter F AF, and then we will have the lowercase letter x single quotes and would be 01 and lowercase letters A and F. And here then red we will have the 0 lowercase letter x 01 uppercase letters A and F, and then 0 lowercase letter x 01 lowercase letter A and F. Illegal hexadecimal literals. So we have the uppercase letter x, and then in single quotes we will have the uppercase letters OG. G is not a hexadecimal digit. The other example is uppercase letter 0 uppercase letter x 01 uppercase letters AF. 0 uppercase letter x must be written as 0 lowercase letter x. So that's what we have here. As you can see in this legal example, this legal hexadecimal, we have 0 lowercase letter x 0 lowercase letter x. So this is illegal here. Values written using uppercase letter x value notation must contain an even number of digits, or a syntax error occurs. To correct the problem, pad the value with a leading 0. So we're gonna check this out. We're gonna open our MySQL. So I'm gonna go into Windows PowerShell. I'm gonna log in with my credential, and it's gonna be like this -p, and it's gonna prompt me for my password. So we type in the password, and now we can just enter. So it's gonna be set, and it's gonna be at lowercase letter s equal sign, and then it's gonna be uppercase letter x, and then we're gonna open a close single quotes. We're gonna end this statement with a semicolon, and inside of the single quotes we're gonna have the hexadecimal FFF, so triple F, and we're gonna press enter, and we're gonna have an error. So we have, let me move this one a little bit here. So we have error 1064. so this is the one that we have here, so let's make it bigger. Okay, error 1064 42,000. You have an error in your SQL syntax. Check the manual. Okay, check the manual that corresponds to your MySQL server version for the right syntax to use near the uppercase letter x, and then single quotes triple F at line, let me see, at line 1. So we have that, and they didn't like that. Why? Because we need to put a 0 before of the triple F. So let's try it out now, and I'm gonna just press my keyboard just the page up. So I have pretty much the same. That is gonna be set space at lowercase letter s equal sign space uppercase letter x, inside of the single quotes I'm gonna have the triple F, but before that I'm gonna type in just 0. So this is the only thing that I'm changing, and we have the semicolon at the end. Press enter, and now it likes it. So we have query okay, 0 rows affected. So yeah, we needed to put this 0 before of the triple F. We have that. Now values written using 0 lowercase letter x value notation that contain an odd number of digits are treated as having an extra leading 0. For example, 0 lowercase letters x triple A is interpreted as 0 lowercase letter x 0 lowercase letters AAA or just AAA. By default, a hexadecimal literal is a binary string where each pair of hexadecimal digits represents a character. So we can just copy and paste it, but for the time being, let's just type it in. So let's move this one a little bit here to the left. Let's move it here, this one a little bit to the left. And okay, it's gonna be select, and it's gonna be uppercase letter X, open single quotes, and inside of the single quotes we're gonna have, well, after the single quotes I'm gonna put a comma just to separate it, but inside of the single quotes we're gonna type in 4D. It's gonna be 79, it's gonna be 53, 51, and then 4C, like this. We have the comma to separate. We are gonna have a char set, and inside of the char set we're gonna open and close parentheses, and after the parentheses we're gonna have the semicolon. Inside of the parentheses we're gonna have the uppercase letter X. After the uppercase letter X we are gonna have single quotes, and inside of the single quotes we are gonna have this hexadecimal 4D 79. Okay, it's gonna be 4D 79 53 51, and then it's gonna be 4C, like this. So we can press enter, and as you can see we have this table with two columns. So the char set is gonna be the X, and then inside of the single quotes we have this number here, and then the binary is gonna be pretty much, it's gonna be 0x and then this number that is the 4D all the way up to the 4C. As you can see, we have two ways to do it here, with the uppercase letter X and with the 0 lowercase letter x. So let me see, what else do we have here? Okay, so we have that. Let me see what else. Okay, so let's try it out, this one, and we can just copy and paste it. Let's just copy and paste it. It's gonna be select, and we're gonna go here. It's gonna be select, and it's gonna be the 0 lowercase letter x, and then this number, comma, space is gonna be the char set, open parentheses, is gonna be 0 lowercase letter x, and then the number, it's pretty much the same number, close parentheses, end up with a semicolon. And then again we have the char set and the binary. So pretty much char set, binary, and here we have the 0x 54 65. So yeah, that's fine. That's what we have here. A hexadecimal literal may have an option character set introducer and collect close to designate it as a string that uses a particular character set and collation. So inside of the brackets we have the underscore char set underscore name. Okay, outside of this brackets we're gonna have the uppercase letter X. Inside of the single quotes is gonna be the value. Outside of that we're gonna have the brackets, it's gonna be the collate, the space, collation underscore name, and the examples are, so we're gonna use this select. Let's check out this example. Let's just type it in, or you can just copy and paste if you want. So it's gonna be select underscore, it's gonna be Latin, and it's gonna be Latin 1 space uppercase letter X, and we're gonna open single open single quotes. Inside of the single quotes we're gonna have this number, is gonna be 4 uppercase letter D 79 53 51 and 4C, like this, and we can just press enter, and we're gonna have, as you can see, we have this table here, underscore Latin and uppercase letter X, and then we're gonna have inside the single quotes 4D all the way to 4C in MySQL, and we can just copy and paste this one. Pretty much we're doing the same thing, we're just changing some numbers, but the syntax is the same. So we are just selecting on space underscore UTF-FAM-B4 space, and then we are having this number, but instead of having uppercase letter X we are having the 0 lowercase letter x, and then the number that is inside of the single quotes, but here we are not using single quotes. Space collate space UTF-8MB4 underscore Danish underscore CI. So press enter, and we have it over here. So as you can see, The example use uppercase letter X inside of the single quotes value notation, but 0 lowercase letter x value notation permits introducers as well. For more information about introducers, you can check out the section 10.3.8 character set introducers. In numeric context, MySQL treats a hexadecimal literal like a big integer unsigned, so 64-bit unsigned integer to ensure numeric treatment of a hexadecimal literal. Use it in numeric context. Ways to do this include adding 0 or using the cast inside of the parentheses we have as unsigned. For example, a hexadecimal literal assigned to a user-defined variable is a binary string by default. To assign the value as a number, use it in numeric context. So we can check out this example. So we're gonna have this table with 2 rows and 3 columns. The columns are gonna be at v1, at v2, and at v3. And the second row is going to be a 65 65. So let's check it out, and we're going to have set, and it's going to be at v1 equals sign, and it's going to be at uppercase letter x. Inside of the single quotes we're going to have the number for the number for 1, but it's going to be inside single quotes. So we have that. Let's also do set. I can just press my page up in my keyboard, and instead of just having v1, it's gonna be v2, and inside of the single quotes it's gonna be 41. But after the single quotes, we're gonna add the plus sign, and we're gonna add 0. So we have that. What else do we have here? So we're gonna do the same thing. Press our page up in our keyboard, and this one is gonna be set v3, and this one is gonna be, well, we can just pretty much change it, and it's gonna be uppercase letter cast. We're gonna open close parentheses, and inside of the parentheses we're gonna have uppercase letter x, and inside of the single quotes, so we're gonna open and close single quotes. Inside of the single quotes we're gonna have the number 41 space uppercase letters is gonna be as unsigned. So it's gonna be like this, as unsigned. Okay, so we have the v1, v2, and v3. So now what we can do is just pretty much is gonna be, we can just select, and we're gonna select at v1 comma at v2, and then finally at v3. So we have select at v1, at v2, and at v3, ended up with a semicolon. And as you can see, we have, let me see the values. So we have, okay, so at v1 is going to be 0 at 41, and then v2 is going to be at 65, and v3 is going to be at 65 too. So we have that. What else do we have here? So an empty hexadecimal value. So in the parentheses we have uppercase letter x, and then single quotes. Evaluates to a 0 length binary string. Converted to a number, it produces 0. So let's check it out. We can, okay, let's type it in. So it's gonna be select, and it's gonna be the char set. We're gonna select the char set. Inside of the parentheses we're gonna have uppercase letter x, and then single quotes like this. There's gonna be nothing inside of the single quotes. We're gonna separate with a comma. We're gonna have the length, open and close parentheses, uppercase letter x, open and close single quotes. We have empty single quotes, and then semicolon at the end. And as you can see, we're gonna have binary 0. So we have 2 columns, char set and length. And the char set column, we're gonna have the binary, and the length is gonna be 0. So we have that. So we can also select x, empty set of single quotes plus 0. So let's see what happens. So let's move it up, and okay, select x like this, and then single quotes, nothing, or empty quotes, empty single quotes, then plus the plus sign, and then 0, and then we end it with a semicolon. So we have uppercase letter x, empty set of single quotes, plus 0, then we're gonna have 0. So the uppercase letter x value notation is based on standard SQL. The 0 lowercase letter x notation is based on the ODBC, for which hexadecimal strings are often used to supply values for the BLOB, or just the black columns, to convert a string or a number to a string in hexadecimal format. Use the hexadecimal or just the hex open and close parentheses function. So we can just pretty much select. It's gonna be select. Okay, select, and it's gonna be hexa. Open close parentheses, send it up with a semicolon. Inside of the parentheses, we're gonna open a set of single quotes, and we're gonna type in the string cat. So press enter, and as you can see, we're gonna have the hexadecimal, open parentheses, and inside of the parentheses we're gonna have the string cat, and then this number is gonna be 636174. So pretty much like that. Then we are gonna select. Okay, so we're gonna select that number. It's gonna be select uppercase letter X inside of the single quotes. We ended up with a semicolon, and then this number. So let's try 636174, and let's press enter. And okay, so in this case, wait a minute, it's the same 636 select, and okay, well, it's just giving us cat, but it's giving us in this way, and this 0 and the lowercase letter x. So we have that. For hexadecimal literals, bit operations are considered numeric context, but bit operations permit numeric or binary string arguments in MySQL 8.0 and higher. To explicitly specify binary string context for hexadecimal literals, use a underscore binary introducer for at least one of the arguments. So let's just let's keep typing in. So it's gonna be set at v1, and it's gonna be equal to uppercase letter x. Inside of the single quotes, we're gonna have the 000 uppercase letter d. We're gonna have this bar here, this vertical bar. Let me see, we're gonna have uppercase letter x. We can just give it some space, uppercase letter x. In the single quotes, we're gonna have 0, and it's gonna be bc, okay, 0 bc 0, like that. Okay, let me see, and we're gonna end it up with a semicolon, like that. And then we're gonna have set, and it's gonna be at v2, it's gonna be equal sign, and let's just copy it here. So I'm just gonna paste it, and let me see, we're gonna have it's gonna be the set at v2 equal sign underscore binary x, and we're gonna have inside the single quotes, we're gonna have 000d, and then we're gonna have the vertical bar, uppercase letter x, single quotes, obc0. So press enter, like that. And now I'm gonna grab the third example, and let's paste it here. So it's gonna be select the hexa. Inside of the parentheses, we're gonna pass in at b1, and then comma hexa inside of the parentheses at b2, and we are gonna have in the hexa at b1 colon and hexa at b2 colon. And the hexa at b1, well, I have the bdd, so I mess it up here. Let me see, bdd. Okay, so it should have been ob. Okay, I type it in d instead of c. Okay, so you can just fix it up. But yeah, and then in the hexadecimal 2, we have the okay, 0 bc0. So we have that. Okay, so now let's move on. The display result appears similar for both bit operations, but the result without the underscore binary is a big integer value, whereas the result with the underscore binary is a binary string. Due to the difference in result types, the display value differs. Higher order 0 digits are not displayed for the numeric result. So that's all that we have for the hexadecimal literal. So let's check out the next section. That is gonna be the the bit value literals. So bit value literals are written using lowercase letter b value or the 0 lowercase letter b value notation. The value is a binary value written using zeros and ones. So again, the value is a binary value written using zeros and ones. Letter case of any leading or lowercase letter b does not matter. A leading 0 lowercase letter b is case sensitive and cannot be written as 0 uppercase letter b. So this is the legal bit value literal. So we have lowercase letter b inside of the single quotes, we're going to have 0 1, uppercase letter b inside of the single quotes, we're going to have 0 1, and then we're going to have 0 lowercase letter b 0 and 1. Illegal bit value literal. So we have b and then single quotes. Inside of the single quotes, we're going to have the number 2. 2 is not a binary digit, so binary digits are just zeros and 1. And then we're going to have the uppercase letters, letter o, we're going to have 0 and then uppercase letter b 0 and then 1. 0 uppercase letter b must be written as 0 lowercase letter b. So as you can see in this example, we have 0 and then lowercase letter b. By default, a bit value literal is a binary string. So let's just type it in the first example, and we can just maybe copy and paste the second one. So it's gonna be select, and then it's gonna be lowercase, well, space lowercase letter b. We're gonna open and close single quotes, and we're gonna type in 0 1, and then it's gonna be 5 zeros. So it's gonna be 1 2 3 4 5, like that. We're gonna separate this with a comma. We're gonna have in the char set. We're gonna open close parentheses and then with a semicolon we're gonna have the lowercase letter b, and then we're gonna have single quotes, and then we're gonna have, let me see, it's gonna be 2 and then 5. Okay, 5 zeros, 1 2 3 4 5, and then 1 at the end. So let's try it in, and as you can see we have the b1 and then a trail of 5 zeros here, and then for the char set we have the, well, okay, let me see, here we have 5 zeros, and here we have 5 zeros, so that's fine. Okay, 5 zeros. Oh, okay, so again I mess up here and there. Let's do it again, and let's just add one. I messed the binary 1 at the end, so that's all I did. So now I have the b, and then single quotes we have 1 and then a trail of 5 zeros 1. The char set is going to be b, single quotes 1, and then a trail of 5 zeros and 1. And then we're going to have the 0 lowercase letter x 41. This is a binary, a representation of a. And let's just copy and paste this one so we don't make mistakes, or I don't make mistakes, so also we can move a little faster. So now it's gonna be pretty much, okay, so it's gonna be select, and we are selecting 0, okay, and then lowercase letter b, and that is the only letter, lowercase letter b, and then 1 1 0 0 0 0 1, and then comma. We're gonna have the char set, open parentheses, inside of the parentheses we're gonna have 0 lowercase letter b, and then 1 1, a trail of 4 zeros, and then a final 1. So press enter, and what else do we have here? So we are gonna have well, okay, that's fine. We're gonna have the 0 lowercase letter b, 2 1s, 4 zeros, 1 char set, 0 lowercase letter b. So this is the binary, and then we have the 0 lowercase letter x 61, since this is a lowercase letter a. Okay, so a bit value literal may have an optional character set introducer and collect clause to designate it as a string that uses a particular character set and collation. So inside of the brackets we have underscore char set underscore name. Outside of the brackets we have the lowercase letter b. Inside of the single quotes we have the value. Outside of that we have brackets, collate space collation underscore name, and we have some examples. So let's just check it out, these examples. So we're gonna have select underscore Latin 1 space b inside, well, we're gonna open single quotes. Inside of the single quotes we're gonna have 1, and then we're gonna have a trail of 5 zeros, and finally a 1. we close the single quotes and ended up with a semicolon, and we're gonna have the uppercase letter A. So that's what we have. And let's check it out, the second example. So we're gonna have pretty much select, and it's gonna be space underscore UTF-8 and B4 space, and then it's gonna be the 0, lowercase letter b, the 1, 5 trails of 0, 1 space collate space UTF-8 and B4 underscore Danish underscore CI, and again we're gonna have pretty much the uppercase letter A. The examples use lowercase letter b value notation, but 0 lowercase v value notation permits introducers as well. For information about introducers, you can check out the section 10.3.8 character set introducers. So in numeric context, MySQL treats a bit literal like an integer to ensure numeric treatment of a bit literal. Used in numeric context, ways to do this include adding 0 or using the cast as unsigned. For example, a bit literal unsigned to a user-defined variable is a binary string by default. To assign the value as a number used in numeric context, so pretty much to the previous section that we were checking out. So we can just check out this example. So we're gonna go here and we're gonna set the add v1, and we're gonna set it to lowercase letter b. Inside the single quotes, we're gonna have the 1 1 4 trails of 0 and then a 1, ended up with a semicolon. So we have that. Let's copy and paste the second one. So we're gonna have, again, we're setting add v2 equal sign b, single quotes 1 1 4 zeros 1. Outside of the single quotes, we're gonna add one more 0. Okay, and then we're gonna have in the star, we're gonna have a v3. We're gonna set add v3 equal sign cast open parentheses. Inside of the parentheses, we're gonna have b single quotes. Inside of the single quotes is gonna be 0 1 1 4 zeros 1. Outside of the single quotes is gonna be as unsigned. So we click OK, we click enter, and then finally we're gonna select those 3 V's, the V1, V2 and V3. So we click it, and we are gonna have for V2 and V3 we're gonna have 97, and for V1 we're gonna have 0 lowercase letter x 61. That represents the lowercase letter a. An empty bed value, so we're gonna have b and then single quotes evaluate to a 0 length binary string converted to a number. A produces 0. So let's move faster, so we can just copy and paste since we went typing it in the previous example. And pretty much we select a char set, and the parentheses of the char set we're gonna have b and then an empty set of single quotes. We separate with a comma. We're gonna have the length open parentheses. Inside of the parentheses we're gonna have the lowercase letter b and then empty set of single quotes. Press enter, and we're gonna have 2 columns, char set and length, and the binary is gonna be 0. That's what we have here. We can also select b, so we can select b, the lowercase letter b, and then we're gonna have an empty set of single quotes. When outside of the single quotes we're gonna add 0, and again it's gonna be 0. So just like in the previous example, bit value notation is convenient for specifying values to be assigned to bit columns. So here we're gonna create a table. So let me see if we need to use, let me see, database. Okay, it's gonna be data, use database, like that. Okay, it's gonna be show databases. Okay, and let me see, it's gonna be, let's use common queries. So it's gonna be use okay, it's gonna be common queries. Okay, so database change, so we're using this database that we created, common queries. And now what I'm gonna do is we're gonna create a table inside of this database. So we're gonna create table, and the table is gonna be lowercase letter t. Okay, outside of that we're gonna open parentheses. We're gonna have the lowercase letter b space. We're gonna have bit, and inside of the parentheses of the bit we're gonna pass in the number 8. As you can see here, we press enter, and query okay, 0 rows affected. So now let's type it in. So it's gonna be insert. Okay, so it's gonna be insert. It's gonna be insert into the lowercase letter t, and we're gonna have a set lowercase letter b equal sign. We're gonna have lowercase letter b, and we're gonna have single quotes, and we ended up with a semicolon, and we're gonna have a trail of, okay, this is 3 8 8 1, so it's gonna be 1 2 3 4 5 6 7 8. Okay, and we just press enter. Okay, that's fine. Let's just copy this one. Okay, so we're gonna insert into the table lowercase letter t. We're gonna set b this time equal sign, and it's gonna be, again, it's gonna be lowercase letter b. Inside of the single quotes is gonna be 1 0 1 0. That's fine. And finally we're gonna use this one. So we are gonna insert into the table t. Okay, so we're gonna set the lowercase letter b, and it's gonna be b inside single quotes. It's gonna be 0 1 0 1, so we can press enter. So that's fine. And now bit values and result sets are returned as binary values, which may not display well. To convert a bit value to printable form, use the numeric context or use a conversion function such as the bin with parentheses or the hexa with parentheses. Higher order 0 digits are not displayed in the converted value. So let's try this one too. And so we have the select, and we're gonna have lowercase letter b plus 0 comma is gonna be uppercase letters b, and the parentheses we're passing lowercase letter b comma OCT, and the parentheses we're passing lowercase letter b comma hexa, and the parentheses we're passing lowercase letter b from the table t. So let's press enter, and it works. So let me see, let's move it. Okay, as you can see, we have the b plus 0. We're gonna have 255. Then we're gonna have in this column we're gonna have 10 and 5, and the bin column with lowercase letter b and the parentheses we're gonna have in this column is gonna have a trail of 8 ones in the first row, and the second row is gonna have 1 0 1 0, and in the third row we're gonna have 1 0 1. In the third column we're gonna have OCT, and inside of the parentheses we're passing lowercase letter b. In the first column here we're having the number 377. Then in the second row we're having 12 or just 1 2, and in the third row we're having number 5. And in the hexadecimal here we're gonna have in the first row we're gonna have double F or just FF. In the second row we're gonna have uppercase letter A, and in the third row we're gonna have the hexadecimal 5. So as you can see, it's pretty much the same. Now for bit literals, bit operations are considered numeric context, but bit operations permit numeric or binary string arguments in MySQL 8.0 and higher. To explicitly specify binary string context for bit literals, use a underscore binary introducer for at least one of the arguments. So let's just copy and paste this example here. Okay, so we're gonna have set at v1 equal sign, and then we're gonna use lowercase letter b. Inside of the single quotes we're gonna have a trail of 4 zeros, 1 0 1 0 1. We're gonna use the vertical, the OR operator, the vertical bar, or just the digital OR operator, logical OR operator. Space is gonna be lowercase letter b. Inside of the single quotes we're gonna have a trail of 3 zeros, 1 0 1 0 1 0. Okay, and then ended up with a semicolon. Press enter. Okay, that's fine. We're gonna do something similar for v2. So we're setting v2, and it's gonna be equal sign, and this time we're setting it to underscore binary space, and then it's gonna be lowercase letter b, single quotes. We're gonna pass in this binary numbers, and then outside of the single quotes we're using the vertical bar, space underscore binary space b, lowercase letter b. Inside of the single quotes we have the 3 zeros, 1 0 1 0 1 0. So press enter. That's fine. And finally we're gonna select hexa Okay, we're gonna select hexadecimals, and we're inside of the parentheses, we're gonna select the hexadecimals inside of the parentheses. Here we're gonna pass in at v1, and then in this hexadecimal is gonna be at v2. So we can press enter, and in this table we have two columns. Hexadecimal at v1 is gonna be 3f, and hexadecimal at v2 is gonna be 003f. So that's exactly what we have here. Okay, so that's fine. The display result appears similar for both bit operations, but the result without underscore binary is a big integer value, whereas the result with underscore binary is a binary string. Due to the difference in result types, the display values differ. Higher order 0 digits are not displayed for the numeric result, and this is what we have for the bit value literals.